By the end of this lesson, we will be able to determine the slope between any two given points. We will use the slope and a table of values to create the equation of a line that connects the points given. The rate of change, or slope formula, describes our rise over run. So this formula for m is still describing our rise over run. Now these triangles, they really stand for delta, which stands for the change in y, or the difference in y values divided by the change in x, the difference in x values. So how much did y change, and then divide by how much did x change. This is also known as y2 minus y1. We have to subtract the y values, see how much they change by, and then x2 minus x1. Subtract the x values, see how much they change by. And these x1 and y1, x2 and y2 values come from two separate points which you must name before using the formula. This should be review from last year, but let's practice together. We are asked to find the rate of change between the following points. Rate of change means m, or slope. We want to find the slope between the 2 points. So we're going to use the slope formula. Before I can use the formula, I must name these 2 points. It does not matter who you choose to name your first point and who you choose to name your second. So I'm going to go ahead and name this one x1, y1 for my first point, and x2, y2 for my second point. Okay, to find the rate of change, I use the formula y2 minus y1 over x2 minus x1. All right, so now let's refer to our named points. I have y2, which is 4, minus y1, which is 5, over, and then x2, which is negative 1, subtract x1, which is 3. So we end up with a m value of 4 minus 5 is negative 1. Negative 1 minus 3 is negative 4. But a negative divided by a negative is positive. So m is 1/4 for problem 1, or rise of 1 and I run 4. I have created this sketch here of both points, 3, 5, and negative 1, 4. Now you can see that between these 2 points, if I was to connect a line, I would rise 1 and run 4 to get to my next point. So the line would be, if I sketch it, something like this, not too steep. Rise 1, run 4. Okay, let's try this one more time. First, we have to find the rate of change, so m. Before I can use the formula, I should name each point. x1, y1, x2, y2. Okay, so now the formula for rate of change, the slope is y2 minus y1 all over x2 minus x1. Let's substitute into the formula. y2 is negative 5. I have to subtract y1. I have to subtract negative 2. All over x2 is 1 minus x1 is 0. Now, anytime I subtract a negative, it really ends up adding the opposite, so adding positive 2, or I could use my calculator and type it in just the way it says, negative 5 minus, and then in parentheses, negative 2, and I'll see that I end up with negative 5, add the opposite, I end up with negative 3 over, and then 1 minus 0 is 1. So our final answer for our rate of change here is negative 3, or down 3 over 1. I have created this sketch here to check my answer, and it shows that from 0, negative 2 to get to 1, negative 5, I do go down 3 over 1. So this line would have a steeper slope than number 1 and would also be negative. This line is decreasing. For examples 3 and 4, we are asked first to complete the table of values, and we're told that it represents a linear function, meaning that there must be that constant rate of change. And then we are asked to write the equation of the function in slope-intercept form, meaning mx plus b form. Okay, so let's start with completing the table. I see that this is going up by 3, and this goes up by 3. So to fill in this value, 0 plus 3 would give me 3. Okay, now I'm not sure what's happening here, but 5 to 6 is adding 1, 6 to 7 is adding 1. So to go backwards, I could subtract 1 from 5, or I could add 1 to 3, and either way, I'll know that 4 belongs here. Okay, we've completed part A. For part B, we want to write the equation in y equals mx plus b form. So y equals mx plus b. Now, b is always our y-intercept. We know that it's always at 0, comma, whatever the b value is. And we can see that value in our chart right here. So b must equal 5. Okay, now to find the m value, or the slope, I can now use my rate of change formula, y2 minus y1, all divided by x2 minus x1. But how am I going to use the formula? I need to name 2 points. Well, I have a whole table of values here. We can pick any 2 points that we'd like to use. So I am going to use the bottom 2 points in the table. All of these values are positive, so it might be easier than dealing with negatives. However, again, it does not matter which formula you use, which pair of points you use, rather. So now here I have x1, y1, x2, y2. So if I substitute into my formula, m will be y2 is 7 minus y1 is 6 over x2 is 6 minus x1 is 3. So now I see that 7 minus 6 is 1, 6 minus 3 is 3. So our m value is 1/3. If I go back to the original equation for every line, y equals mx plus b in slope-intercept form, I now see that y must equal 1/3 x. My slope is 1/3, up 1/3. So 1/3 x, and then plus my b value, or I begin my graph at 0, 5, so b is 5. This would be the equation of the line shown in the table for problem 3. Now would be a great time to pause the video, try this problem on your own, and then press play to check your answer. Please use problem 3 to help you. Okay, so as you check your answer, first notice that we had to fill in the table of values. I realized that there was a pattern of adding 1, so I added 1 to -6, became 1 less negative, so it's -5, and then I added in the -2 here. For the y pattern, it's changing by decreasing by 2. So if I continue that pattern, 5 belongs here, 3 minus 2 is 1, 1 minus 2 more is -1. Okay, so now I know for part B, I have to write the equation of the line. For B, I don't see the y-intercept. So instead, I found the slope first. I used the slope formula. I chose the first 2 points. If you chose any other pair, you could use the first point with the last point. You could use any of the middle pairs. It does not matter. All of us should have the same slope of -2/1, or m equals -2. Okay, so now I want to write the equation of the line. So I have y equals, we know it's -2 times x, so -2x, and then plus, now our b value. Our b value can be found by extending this table. If I add 1, I see that I have 0 here. Now let's continue this pattern. -2, so -1 minus 2 more is -3. Our line must cross the y-axis. Our y-intercept must be -3. So to simplify our equation, I would rewrite this as y equals negative 2x minus 3. We are now able to determine the slope if we're given any 2 points, whether they're in a table or just given to us as in xy ordered pair form. And we can also use that slope or the table to create the equation of the line we are given.